Hello again. Let us solve the present problem. Read the problem. Let integers AB belongs to -3 to +3. Okay, this is the condition. Only integers they are saying. That means A can be -3, -2, -1, 0, 1, 2, 3 you can take. And also B can be taken -3, -2, -1, 0, 1, 2, 3 you can take. And A plus B should not 0. A plus B should not 0. That means you cannot take first and last values in the same distance. That means -3 plus 3, okay, -2 plus 2 in that way should not take. So how many possible ordered pairs are there if you mingle with everything? So here 10 combinations with each element can be mixed with 10, all the 10 elements. So 10 elements is 10, 10, 100 possibilities is there. 100 ordered pairs you can create using these ordered pairs A, B. Total ordered pairs you can create 10 elements. You can combine with remaining 10 elements. Total is 100. But if you mix with this condition, A plus B not equal to 0, then how many conditions are 0? So out of these, -3 plus 3, 0. -2 plus 2, 0, and -1 plus 1, 0, and 0 plus 0 is also 0. So 1, 2, 3, 4. 4 with 4 are selected and remaining were fixed. So out of these 4 ordered pairs are selected, they should make 0. So what are they if you want to see? -3 plus 3. Of course, if you reverse this element also, it will be same, -1 plus 1. And also 0 plus 0. Okay, 4 plus 4 into 4 or 4 plus 4? 4 plus 1 is fixed, another one AB and BA. Okay, both we testing. So 8 elements is there like that. Now, along with this, he make one more condition that it says, okay, keep it away, these things. I hope you understood what is the condition says. Z minus A by Z plus B under modulus equal to 1. That means you can write Z minus A under modulus is equal to Z plus B. If you do cross multiplication, you will get this scenario. Okay. Next, he wants to solve the one det value. So copy that det value. Det of Z plus 1, omega, omega square, and omega, Z plus omega square and 1, and omega square 1 and Z plus omega. He said it is 1. So let's solve this. I am doing in R1 plus R2 plus R3. Okay. After performing this operation, we will see Z plus 1 plus omega square and omega plus Z plus omega square plus 1, and also what is that? Omega square plus 1 plus Z plus omega. And all these det values are equal to, okay, understood, 1 and Z plus omega. Now we know that 1 plus omega square, 1 plus omega square is 0. So in such case, you can see numerator Z plus 0 and also Z plus 0 and also Z plus 0, and remaining omega square, Z plus omega square and 1 and Z plus omega, it will be equal to 1. So take Z common, then 1 and omega Z plus omega square 1 and omega square 1 Z plus omega. From the first row, I took a common, that Z. Okay. And now in C2 and in C3, what I am doing? I am doing C2 minus C1, and in C3 minus C1 I am doing. Okay. So then Z of 1 omega square, and this is what? 0 and 0, and this value will be z plus omega square minus omega, and this is 1 minus omega, and 1 minus omega square, and z plus omega minus omega square equal to 1. So from this, if you perform that determinant rule, so one of these two multiplied, okay, z plus omega square minus omega multiplied with z plus omega minus omega square minus 1 minus omega into 1 minus omega square. It should be equal to 1. That means after solving all these values, you can observe that these two things got cancelled. Let me solve this thing. Z into Z square plus omega Z minus omega square Z plus omega square Z plus omega cube minus omega power 4 minus omega Z minus omega square plus omega cube minus of 1 minus omega square minus omega plus omega cube, and is equal to 1. Now omega square Z and omega square Z got cancelled. Omega Z got cancelled. And omega cube. Okay. Now Z of, what is this value? Z square. Z square, what left here? Omega cube 1. This is minus omega power 4 is minus omega. And minus omega square, and again omega cube is 1. And then minus 1 plus omega square plus omega minus omega cube is 1 equal to 1. Okay, now you can see plus 1 minus 1 cancel, plus 1 minus 1 cancel, omega square cancel, omega cancel, complete all cancel except z cube 1. So this means z is equal to 1. Okay, so after getting z is equal to 1, we will implement this value here in this rule. So these ordered pairs, whatever we calculated 100 at first, and then we deleted because sum should be not 0. After that, we will have 92. And now they must satisfy this property, this A comma B, they must satisfy this distance property also. So after all, after calculating, verifying this filter also, we got only 10 values. 10 values are ordered pairs. Okay. So you can try that ordered pairs by satisfying this property. That means if you substitute A value 1 and B value 1, you can write that, right? You can write, because now, if you substitute 1, this value will be minus 1. This is the actual filter you should apply, 1 and minus 1. Okay, that is one ordered pair. Okay. Similarly, you can write 2 and minus 2. In that way, you can create only 10 values. Try yourself.